Welcome back to my 12-part inverter review, and today we're going to jump right back into it with inverter number 9. Now, this inverter is actually the most expensive one out of the 12 that I'm going to be covering. However, I'm covering it next because I'm doing these in order of rated output power, not price. And this inverter is the GoPower SW2000. Now, this is 2000 watts, like the previous inverter that I had talked about. However, this one is about 4 times as expensive. Why does this one cost so much? Well, this is the first inverter of the ones that I've covered that is specifically designed to be used in a permanent hardwired installation. It produces clean, reliable power, and its build quality is durable and long-lasting. And it also has one feature that none of the others have. And that feature is right here. Pure sine wave DC to AC power inverter. All of the previous ones that I've covered are modified sine wave. I had done a video on this earlier, the differences between a sine wave and modified sine wave inverter. You can check that out if you're interested. But that is part of why this inverter costs so much more than the other ones. Now, they do sell sine wave inverters that are much lower quality. A lot of them are Chinese origin. This is not one of those. This is actually a higher quality unit to compete with the likes of some of the greater name brands out there. The box doesn't say a whole lot about this particular inverter. It gives a continuous rating, a surge rating, and I believe that this is actually a true surge rating. I think it does that for 10 seconds or so. Output voltage 110 volts, minus 10%, plus 4%. The output voltage is actually settable with some internal dip switches from 110 to 125, I believe, volts. So you can set that. Input voltage range, efficiency 89%. This looks low probably because they're more honest than a lot of the other manufacturers. However, sine wave inverters do tend to be slightly less efficient than modified sine. However, the load, your appliances that you power off of them actually are more efficient off of sine wave than modified sine, so your overall system efficiency goes up, even though this number is a little bit lower. Gives you the height and weight and everything, and the no load draw, 36 watts. That's actually fairly high. The 3000 watt unit is a little bit more efficient, and it has a little bit lower no power draw considering its 3000 watt size. I would recommend that one, except it costs a lot more. But for a sine wave inverter, that's not terrible. It's not great, but I'll accept it at least. Alright, let's see what we've got here. Open up the box, and they give you a user manual, of course, and a bunch of other miscellaneous hardware. A couple of heavy-duty rings to crimp on cables, and of course the inverter itself. So let's pull that out. Set this aside, and here is the GoPower 2000 watt sine wave inverter. This one I actually purchased brand new, and I'll tell you more about that story later. But it has the input power cables here. Chassis ground lug, a couple of quiet cooling fans, a remote port for turning it on and off. This also has an optional remote that shows battery voltage, load conditions, error modes, that sort of thing. I don't have that remote. And on this side you have your power switch, a couple of settings to change the frequency between 50 and 60 Hertz, a power save mode, so that this will shut down when there's no load. All those modes are talked about in the manual. I'm not going to cover those. And here is the hardwire port. You can unscrew this and have an electrician or yourself, if that's legal in your area, hardwire this into your building to a transfer switch or something, and then another auxiliary outlet, which is what I have used so far. But the feature that I like most about this inverter is the exceptionally clean output power. This is the sort of inverter that you could have hooked up to lights, and when your refrigerator starts up, you won't even notice. It is very, very clean power. I was extremely impressed with it. I couldn't get the output voltage to fluctuate even 1 volt no matter what I did, and it was always a perfect sine wave. I didn't have an actual power analyzer hooked up to it, but this is very good quality output power. I was impressed. A few of the things that I don't like about it, and maybe this is nitpicking, but these terminals are too close together. If you for example, loosen this bolt up and slide this out, it actually contacts the negative post, and you really should have a fuse in your line anyway, but these should be separated more so you don't have accidental contact. Shorting out a bank of large batteries could be a pretty serious thing, and I would prefer to see these further apart. The other main negative that I have about it is that I think they're trying to get you to buy their overpriced remote because the only indicators that they give you are 3 LEDs. Now on an inexpensive inverter I wouldn't have any problem with that, but if you're paying $800 for something, can't they at least put a display on it that shows you some real information, battery voltage, load conditions, whatnot? Instead they just use 3 LEDs. I think that's kind of cheap on their part. But those are the main negatives about it. Now I purchased this inverter kind of by accident. I was browsing an online auction site one day and I noticed that there was this very expensive inverter going for very cheap, and there's only a few minutes left. So I just placed a lowball bid, and what do you know, I ended up with it. But the seller didn't seem too eager to sell his inverter at that low price. It wasn't the most honest person, and we actually went back and forth for probably a couple of weeks before he finally gave in and shipped me the product. I was half expecting to open up the box and get shipped to cinder block or something, but fortunately that didn't happen. I actually got an inverter out of the deal. Now I did run into one problem with the inverter. I pulled it out of the box, I was all excited, I tested it out, and I ran into a problem with it. Let's take a look at the ratings on the box here quick. And specifically I'm talking about the input voltage range. 10 to 15 volts is what it says on the box and in their advertising media. If we take a look at the user manual for the GoPower SW2000 12-volt version, the input power range is 10.5 volts to 15. It doesn't match their box. If we go over to the inverter, here's the label that's on the bottom. It says 11.5 to 16 volts. And if you go over to the input side over here, DC input, they have a sticker on it that says 11.5 to 16 volts. Now, 16 volts is great, but 11.5? Really? The problem I had is that every time I put this inverter under a load, it acted like the voltage sense on it was 1 volt off. As soon as the voltage dropped below 12 volts, it would start beeping and complain that the voltage was too low, and 12 volts is not too low, so I'm not sure why it was doing that. And then it shuts down at 11.5 volts. Now, I'm not sure if this inverter is defective or if I got a special non-battery rundown model or what's going on here. But I can't think of any situation where an inverter with this input voltage range is actually useful to anybody. So I wasn't quite sure what to do, and I'm not able to test it fully because of that. Now I tried to work this problem out with the seller over the course of a couple of weeks, and I never really got anywhere. So the last place I left off, he agreed to take the inverter back if I shipped it back, and then he would refund my money. However, I would be out the shipping charges, and this is pretty heavy, so it's fairly costly. And I'm not entirely sure he would have refunded my money. Like I said, this wasn't the most honest character out there. So I decided to just cut my losses and keep the inverter. After all, I didn't pay a whole lot for it compared to what it sells for new. So I'm not sure what to do with it now. It seems like a really, really nice inverter, but the voltage range is off, input voltage range. So, I don't know. I just got off the phone with GoPower customer support, and I have some good news. First of all, customer support is based in North America, which is awesome. Second, they were able to tell me almost immediately why my inverter wasn't working. And third, they gave me an RMA with no hassles, even though I don't have a receipt. So I should be able to ship this inverter off, and in a month or so, have one returned to me that actually works the way I expect it to. Now, the problem with this inverter is not that it's broken, it actually is working perfectly, but I was told that this is a fleet unit, which is not intended to be sold to the public. Now, the fleet units are meant to be used on work trucks, large straight trucks that run constantly while they're in use, with very large alternators. And I can see why they would want a voltage range like this, up to 16 volts, so that it can operate in extremely cold weather when the alternator voltage is high. and shut off at 11.5, so you can always start your truck. But it's not useful to me, and it's not useful to very many people out there. So I'm going to exchange this for one that is useful, and I'll decide there whether I keep it or sell it. But my good mood is not going to last, because next up we're really going to be scraping the bottom of the manure pile, and I'm going to be talking about the Durafied S3000Di. First, let's talk about the good things. The packaging. I bought this new, and it came double boxed, double layer cardboard, plus an inner box. It has a user manual, which is all of one page. This empty plastic bag here had cables in it. These are the cables that came with it. They are about 3 feet long, and they're approximately 1 gauge. The rings on the end are adequate and nothing more. I've used them, they seem to work okay. As far as the cable size here, if you take a look at it, they are 35 millimeter cables. I believe that's 1 gauge, maybe it's 2, I'd have to look it up. Which is fine, but they are in metric, and when you're in North America and you buy a product that's in metric, you can be sure it came from China. So these cables are probably not very good quality. If you're in Europe, it's just fine if they come metric, but I don't like it here, simply because I know their origin. And the inverter itself is inside, so let's pull that out. And now with all the packaging removed, you can see the actual inverter. 3,000 watts, 6,000 peak. 6,000 isn't true. I'll get to that. On the end there's 4 outlets, nothing too spectacular, a switch and a remote. They don't sell the remote with it, I don't know where you buy it. It's pretty irrelevant. You can open it up and just put an ordinary switch on the 2 pins if you have a soldering iron. The case is extruded anodized aluminum, just like basically all of them. Pretty standard. No complaints about the case itself. On the end over here we have dual cooling fans. They use small diameter fans, which are going to be noisy and won't last long. That's a sign of being cheap. And they have these massive input terminal lugs. I open it up and the cabling inside is barely adequate, but I don't really know where you buy terminal rings that fit these, and you're going to need 0 gauge wire or so, probably quite a bit heavier actually, for a 3,000 watt inverter. So my strategy is just to buy some good quality 100% copper rings and drill the hole out until they fit. That's what I do anyway. You can do whatever you want. I know that some people buy or cut up copper pipe and just bend those. So whatever suits you. But here it is, the inverter, physically. So what do I think of the Durafied S3000Di? Well, I call it a piece of crap, but that isn't really fair because it's a whole crap. This inverter is terrible. Stay away from it and stay away from the Durafied brand. If you open it up, you can see that the construction quality is extremely poor. It's the worst one of all of them that I'm showing today. For example, just take a look at the fans that they put in it. They're made by Hengfu. Yeah, Hengfu. And if you take a look at this end, this is something that you should look for at any inverter in this class, 3,000 watts. It has 4 outlets, which are extremely cheap quality, by the way. And there's no hardwire option. Something like this really should have a hardwire options to the live neutral configuration, which is what this one has. It makes it far more useful, and it's a sign of a better quality inverter. So the overall build quality is poor. I don't like the features of it. It's not going to be reliable. But also, it just doesn't work well. It's a 3,000 watt inverter, 6,000 peak. However, in terms of the loads that it can start, this one is inferior to that stat power 1500 watt that I had shown earlier. 3,000 watts, 6,000 peak, but it can't even power a load as large as a 1500 watt inverter. And that is pretty sad. So, this inverter, stay away. And you know what's really frustrating to me? It's not the fact that this is a bad inverter. After all, you're looking at somebody who's made a habit out of buying bad inverters and repairing them. But with those, at least once they're fixed, you might have something half decent. With this one, well, all you have is this. No, the reason that it's so frustrating to me is because this is one of the first inverters that I bought, and is largely responsible for why I'm hoarding so many today. I thought, you know what, I'm going to buy myself something nice. Little did I know,
all I was going to get myself was pissed off. But I don't want to talk about this a whole lot more, because it'll put me in a bad mood. So, what I'm going to do now is cover the second to last inverter that I have, which is the MotoMaster Eliminator 3000 watt inverter. And this one is actually my favorite out of the 12.